everyone! Today I'm going to demonstrate how to make a marble. In this lesson, you will learn how to gather glass in bigger scale with a wider flame and then how to shape it with a marble mold. You will also learn more about proper annealing process. Before we start the hands-on, I would like to cover thermal changes in glass a little further. In the last lesson, I explained that glass molecules move more energetic when the temperature goes up. Glass is pretty unique material. It is hard and rigid at around the room temperature. When the temperature goes up, the bond between the molecules get loosened, so they move more freely. The glass gets softened, the viscosity changes. Later, it acts like a honey. It is very dramatic changes. The temperature that glasses start to move is called a softening point. When the temperature goes down, glass molecules start to structure more rigid form. The temperature is called a strain point. The strain point is very important in glass making process since glass easily earns stress at the point. It is not really a big problem when your glass is thin. It becomes more problematic when your glass is thick. Let's say this is an inch thick glass and then we are heating it with a torch flame. When the outside temperature hits 515 degrees Celsius, the glass molecules on the surface are ready to change their structure. But the molecules inside is still cold and hard, and the gap between the inside and outside causes internal stress. The stress can crack or chip the glass. If we keep heating the glass, eventually the temperature of the inside will catch up and the internal stress will disappear. The molecules are all flexible and lively at the working temperature. This is a safe zone that glass will never crack. When we finish heating the glass, the temperature on the surface will drop much faster than the core. When the outside temperature becomes 515 degrees Celsius again, the surface gets stiffened while the core is still soft. And again, the temperature gap causes internal stress. When the stress becomes too great, the bondings break and the glass will crack. Then, how can we avoid the internal stress? How can we avoid the thermal gap? Simply to say, heat slowly and then cool slowly. The slow heating process, we call it preheating. You can use a kiln set around 565 degrees Celsius and pick up your glass from it. Or you can use the tip of the torch flame to warm up your glass slowly. While forming, try to keep the temperature above the strain point all the time. Once forming is done, it is time for slow cooling, which we call annealing. Above the strain point, the molecules are flexible enough to endure the thermal gap, so we can drop down the temperature fast to near the strain point. However, slightly above the strain point, we have to stop the drop down and hold the temperature for a while to soak the glass. The purpose of soaking is to make sure that inside and outside temperatures of the glass are the same. The holding temperature is called annealing temperature. It is slightly above the strain point. Each glass has different annealing temperature. The annealing temperature of a borosilicate glass is 565 degrees Celsius. The annealing temperature of soda-lime glass is 515 degrees Celsius. The soaking time varies by the thickness of the glass. Once the soaking is over, drop the temperature very slowly until it passes the strain point. Once it passed the strain point, drop the temperature a bit faster to the room temperature. This is the end of the proper annealing. Let's look at the shape of the line graph. There's a big hill and a small plain in the middle of it. This is a typical heating cycle of a flameworking. The proportion can vary by the type and the thickness of a glass, and you can put multiple steps for a more conservative setting. However, the basic shape will remain the same. Same as preheating, annealing can be done by a torch or a kiln. Our Paragon kilns are already programmed for a proper annealing. You will learn how to program it next year. Until then, just make sure that the temperature of the kiln is 565 degrees Celsius when you put your pieces in. Today's demo, you would notice that there's a lot more heat involved. Make sure to drink water more often. You can bring a water bottle with a lid in the studio. Thanks for watching. See you next time.